Alright, welcome back to Saxon Math 54, and we are looking at Lesson 89. In Lesson 89, we're going to be talking about mixed numbers and improper fractions. Let's start here with our warm-up, and I would encourage you to spend a little time warming up using these problems here. I'm going to just talk briefly about the one that deals with patterns. There are patterns all over the place. Much of mathematics is just discovering patterns and the beauty of those patterns. So our world is filled with them, and we get to discover them and see how they apply to our world and see how we can use them. So in this case, these patterns here, it says 15 dots can be arranged in a triangle, as you see right here. 16 dots can be arranged in a square. So 16, that would make sense because it would be 4 by 4. 4 times 4 is 16. So you have 4 rows of 4. And it says here then 36 dots. 36 dots can be arranged in either a triangle or a square pattern. Make a triangle and a square pattern using 36 dots. So we're looking for patterns here and how we can maybe take these 36 dots and put them into these patterns. Let's start with the square. As I mentioned over here, a square, to find the area of that square, you take side times side. So to get the 36 dots placed into a square arrangement, probably we're going to have 6 by 6. 6 times 6 is 36. So you're going to make a row of 6 and then another row of 6, and you're going to make 6 rows of 6 to have your square that is 6 by 6 for a total of 36 dots. Triangle is a little more difficult, but my suggestion would be to start at the top with the 1 dot, the row of 1, and then work your way down. So let's start 1, and then we'll just count, and we're going to count up to 36 and see if we get a triangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we're at 15. Notice that each row is going to have one more dot in it. So the first one had just 1, then 2, then 3, 4, 5. So we were at 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, and 36. Perfect. So there's your triangle using 36 dots. Alright, let's come down to today's new concept. And today we're looking at, remember, mixed fractions, mixed numbers, and improper fractions. So here we show a picture of 1.5 shaded circles. So this 1 right here is for the entire circle, a complete circle that is all shaded in. And then this second circle, we have just half of that circle that is shaded in. Okay? Each whole circle has been divided into 2 halves. And the reason for that is because since this one is divided into halves, into a half of it is shaded, then we might want to divide this other one into half to count how many halves are shaded. So this one that is completely shaded, we divided it into half as well, and we notice that we've got this half and the second half. The top and the bottom half are both shaded, so that's 2 out of 2 halves. So 2 halves. And then in this one, only 1 of the 2 halves are shaded. So the first one, 2 out of 2, they're both shaded. The second one, only 1 out of 2 is shaded. So that's a total of 2 and 1 is 3. And how many halves are shaded? Do not add the bottom denominator numbers. Do not add those denominators. It's 2 halves plus 1 half is a total of 3 halves. So remember, you have a total of 3 halves that are shaded. We're counting how many halves are shaded. 1, 2, 3 of all of the halves are shaded. So 3 halves are shaded. Okay? Another way to write that is 1.5. If you take 3 and you divide by 2, 3 divided by 2, 2 goes into 3 one time, with a remainder of 1 left over. And you write that as 1, the remainder, over the half, over the 2. We'll talk more about that. Okay? So you can see from the picture that 1 1/2 is the same as 3/2, which is written as 3 over 2. These two values, 1 1/2 and 3/2, are exactly the same value, but they're just written differently. And that's what we're talking about when we talk about a mixed number. So this is a mixed number because it has kind of two parts to it. It has the whole number, the 1, and then it has a fraction part. So it's kind of mixed. It has two different looking numbers to it. And then this 3/2 is called an improper. That's an improper fraction. But they have exactly the same value. They just have two different ways of writing it. Okay? The numerator is greater than the denominator in 3/2, so the fraction 3/2 is greater than 1. Anytime the number here in the top, the numerator, is larger than the denominator, then that value is going to be bigger than 1. As you can see, it's 1 and a little bit more. It's 1 1/2, so it's more than just 1. Fractions that are greater than or equal to 1 are called improper fractions. And in this lesson, we will draw pictures to show mixed numbers and their equivalent improper fractions. Notice it says equivalent. That's important. The mixed number and the improper fraction have the same value. They're just written in a different form. So here's an example. Draw circles to show that 2 3/4 equals 11/4. This bottom number right here is telling you what you need to divide the circle into, what you need to divide the unit into. So this circle right here, actually all the circles are divided into quarters, into fourths. So you'll notice that you have 2 and a little bit more than 2. So that means you're going to have 2 full circles, and then the third circle, not all of it's going to be shaded in, but you're going to need 3 circles. So you have 2 completely shaded in circles. That's this one and this one. And then you have 3 of the fourths shaded in. So all 3 circles are divided into quarters, into fourths. The first 2 are completely shaded in. And the third one, you have 1, 2, 3 of the fourths shaded in. This fourth one is left empty, and that's why you only have 3/4 as your fraction part of the mixed number. Okay? So 4/4, 4/4, and 3/4. If you add just the numerators, 4 plus 4 plus 3 is 11. Do not change the denominator. It's telling you how many fourths you have in total. So don't add 4 plus 4 plus 4 in the denominator. Your denominator is just 4. You're just counting up how many fourths you have shaded. Okay, so there are 11 shaded fourths is what they're saying. The other way to say that is you've got two complete circles, and then you've got 1, 2, 3 of the fourths that are also shaded. So 2 and 3/4. So let's look at this practice set here. It says draw circles to show that 1 3/4 is equal to 7/4. So 1, you're going to have a complete circle. All of those are shaded in. And then you're going to have another circle, but only a portion of that is shaded in. How many? 3 of the fourths. So 1, 2, 3. And that means you've got 1, 2, 3, 4, 5, 6, 7/4 that are shaded. I'll let you do B and C. You might want to pause and do B and C, and then come back and check to see if we have the same solution. So we have 2, so I know 2 of these are going to be completely shaded in, and then 1 out of the 2 on the third one. And that's 1, 2, 3, 4, 5 halves. And then the last one here, 1 and 1/3, so 1, and notice we're dividing into thirds this time. It's a little harder, but do your best. Just divide it into 3 equal parts the best you can. So all of this is shaded in, and then 1 of the thirds is shaded in over here. Okay? So 1 3/4 is the same as 4/3. 1, 2, 3, 4. 4/3. Okay? Alright, we're going to look at the mixed practice here. You can pause this and go through your problem set and then come back and you can look at some of my comments. But if you feel confident with what you did, you can just stop the video here and work through the problem set and check your answers. Otherwise, come back and we'll talk about some of the problems in the problem set. Alright, let's look at this problem set. We have problems here. Actually, this one is, our first one deals with the last lesson we just talked about. So the coach divided 33 players as equally as possible into 4 teams. How many teams had exactly 8 players? So you can take these 33 players and you are going to equally into 4 teams. So take these 33 players and divide them into 4 teams. That means you're going to take 33 divided by 4. You're going to find out what that is, and then there may be some players that don't fit on one of those 4 teams because there's too many. Okay, so if you take 33 divided by 4, you're going to get 8. 8 times 4 is 32, but that's not exactly 33, so when you subtract you get a remainder, R, remainder of 1. So you're going to have 4 teams that have 8 players. But then you're going to have 1 left over. Okay? And so what if you had 9 players? So if you took 33 and you're going to divide by 9, well, 33 divided by 9, what's 33 divided by 9? If you take your 4 is going to be too many because we already figured out that 4 teams gives you about 8 on a team with 1 left over. So we're going to go to 3. So 3 times 9 is your 27. 33 minus 27 is going to give you 6. You have 6 players left over that are not going to be on a team if you have 9 each. So you're going to have 3 teams that each have 9, but you've got 6 players that are left over. So that would be something to consider as you're making up your teams. Alright, on the package there were 2 37-cent stamps, 2 20-cent stamps, and 1 15-cent stamp. Altogether, how much did the stamps that were on the package cost? So you have 2 37-cent stamps, 2 20, and 1 15. You have to add all those up together. 37 plus 37, 20 plus 20, and 15, and you find the total cost. Daniel read 20 pages each day. How many pages did she read in 2 weeks? So 2 weeks would be 14 days. And then you're going to take 20 pages each day. Notice the units here, days and days here. So notice how I set it up, 20 pages per day. The days are going to cancel, so this tells me I'm going to take 14 times 20 in order to get my answer, how many total pages. The Frog Prince left 27 feet to get out of the well. How many yards? Well, there are 3 feet in 1 yard. So if you go 27 feet, you're going to divide that into by 3. So if you take 27, and you divide that by 3, you're going to get 9. So that's 9 yards. And again, if you want to look at the unit multiplier, this is a good practice. You're going to take your 27 feet that is given, and then using this conversion right here, 3 feet is equal to 1 yard, you're going to multiply by that conversion. You always put the unit that you're trying to get rid of, which in this case is feet, in the denominator, and then the one you're going to, yard, in the numerator, and then put in these numbers. 3 feet, 1 yard, and this tells me what I need to do. In order to cancel feet and go to yards, I'm going to take 27 and divide. Notice 3 is in the denominator here. 27 over 3, 27 thirds. So 27 divided by 3 is your 9. Perimeter, you're going to add up all of these sides, the distance of all the sides, That'll give it to you in millimeters. And then you are going to convert it to centimeters, because there are 10 millimeters in 1 centimeter. Okay? Tally 5, 5, 5, and 3. Add those up. About how much liquid is in this medicine dropper? Well, 2 liters would be like 2 bottles. That's too much. 2 pints would be a little bit smaller, but still that's too much. 2 milliliters, that's a smaller amount that you should be aware of, and that's what your eyedropper is. 87 plus 0 equals 87 times n. So in this case, you're going to, let's evaluate the left side. 87 plus 0 is 87. And then on the other side, you've got 87 times something. This is your question mark. Anytime you see a letter here, it's asking you a question. 87 is equal to 87 times what? Well, hopefully you see that that is 1. But if you don't, you could also just divide both sides by this 87 to cancel it. That's a little bit of some algebra, but that's just a little, maybe getting ahead of ourselves here. But in any case, you're trying to answer that question. 1/3, you should show 1/3 right there as a fraction of 24. Of often means multiplication, so 1/3 times 24 finished early. How many students finished early? You take 1/3 of 24 in order to get your answer, and you can draw that picture. What percent of a dollar is a quarter? So a quarter, just by its name alone, hopefully you see that a quarter is 1/4 of a dollar, or 25 cents. And that's 25% of a dollar. Or sorry, yeah, it's 25% of a dollar, okay? It's a quarter of a dollar. All right, I'm going to let you do 11 through 24. How much is 1/4 of 10? If you take 1/4 times 10, or 10 divided by 1/4, you're going to take this right here. You're going to do this division and find out what is 1/4 of 10. And keep dividing it out until you get, notice this is dollars here, divide it out until you get to the hundredths, because you want dollars and cents. Draw and shade circles to show that 1 1/2 equals 3 halves. So 1 and then half. So I want a total of 3 halves circled, or 3 halves shaded, sorry. 1, 2, 3 halves. Draw a rectangle that is 5 centimeters long and 4 centimeters wide. Okay, so it's going to be longer than it is wide. But you can actually use a ruler and measure that out to get exactly 5 centimeters and 4 centimeters for your dimensions. What is the perimeter and area of the rectangle you drew in problem 27? So the perimeter is going to be, add up all the sides, 4 plus 5 plus 4 plus 5. The area is going to be 4 times 5, and it would be in square centimeters for the area. The perimeter is just going to be in centimeters. In this polygon, which side appears to be parallel to side BC? So this is BC. The side parallel to it would be DA. And last one, which 2-digit number less than 20 is a multiple of both 4 and 6? So 2 digits, it has to have 2 digits in it, less than 20, so we can't go above 20, is a multiple of both 4 and 6. Well, if you don't know, multiples, by the way, are, if you count by 4, 4, 8, 12, 16, and we can't go above 20, right? And then if we count by 6, 6, 12, 18, you can't go above 20. So which 2-digit number, it has to be 2 digits, so we can cross out those aren't 2 digits. Less than 20, all these are less than 20, is a multiple of both 4 and 6. Which of the numbers appears in both lists? And that would be 12. Okay? So keep up the good work, and we will see you next time.